Assalamu alaikum. Hope all of you are doing great. Welcome to our today's session. Yesterday we finished manipulating data frames um, and we covered the topics of sorting and grouping. Definitely there are many other types by which this sorting and grouping can be done, but when it comes to uh, more when it comes to more application oriented, then these things will become more and more clear. For now, the basic grouping and basic sorting stuff is um, covered for you so that you have at least some idea how it can be done. Today we are going to start our new topic, which is EDA or exploratory data analysis. Till now, whatever we were doing was all about calculating, finding out some values, or everything was circulating around numbers. Being a data scientist, you need to showcase your data as well in order to make your analysis more presentable and more engaging to the audience. For that purpose, we need to do this EDA, right? Also, it make it easy in pictorial view to understand what it is all about, what you can extract from your data, rather than going into the calculations and tracing the numbers from where you are getting what, right? So in simple words, we will be doing some plotting of graphs, right? And for that we will be using a new library which is called matplotlib, right? Matplotlib, it is an amazing visualization library in Python for 2D plots of array. It has multi-platforms that allows you to do the data visualization, and it can create several plots like line, scatter, bar, and histogram. These all are 2D plots, and we will be covering all of them one by one, right? So first we will see how to import the library. To import the library, you need to use this syntax: import matplotlib.pyplot as plot. So once this syntax is written and you execute it, this library is imported, right? Now first, this is the most common plot. Most of us very familiar with this line plot. What is a line plot? In this line plot, usually we have two sets of data, usually in X and Y form. And when we plot them, so we got a line in between these 2 points. Now let us understand how it can be done. So first you need to import the library, then define X and Y data sets, and then plot, which is calling the library dot plot. Plot means line plot, X comma Y. So it will take X from this and Y from this, and then plot show will give you the output. You need to make sure that if it has 1, 2, 3, 4, 5, if X has 5 values, then Y also must have 5 values. If this is not matching, then this will not work. For example, if I make it like this, now you will see it will give you an error because both of these are mismatching, but now they are matching. So now you can see that you have a value, you have a output here which is in the form of line graph. Now as we taken these values randomly, so you can see this line graph is not making any good sense for us, because it is increasing, decreasing, again increasing, and it is like something this which is not so clear. So let's make this data more um, linear, you can say 5 and 6, and here we can say this is 10, 20, 30, 40, 50 and 60. So we made this data linear. So you can see here very nice plot, but in real world scenario this is not the case all the time. You will have whatever the value and you will have the graph based on those values. So then you need to modify, you need to see what to do with that, right? Now here you have a task, you need to use the range function to create a list from 1952 to 101, right? Why 211? Because we are interested till 2100, right? So if we give the range to from 1950 to 2101, that means it will bring all the values till 2100. If we write here 2100, then it will bring one less than that, right? And then you have a population list given in billions for the same respective years, and you need to print the last year which is 2100 and the last population which is 10.85 from it, right? So this is the first task that you have to do. So now you can see here, if you want to print year as well, so you can print that. So here we have years, all of them from 1950 to 2100, 50 years, and this is pop, so we can print pop as well. So first list for the year, second list for the population, then print last year and last population. So last year is 2100 and last population is 10.85 billion, right? Now both of these lists have 50 elements in it, so we can clearly draw a line plot in between them. When we draw a line plot in between them, you can see here it is gradually increasing from 1960 to 2100, and it is approaching about somewhere 10 or 11 billion somewhere, right? Now we have another example in which we have some savings per month that are mapped against month. So we have 12 months and 12 savings. Simple line plot. Here again you can see here sometimes it is increasing, decreasing, more increasing, decreasing. So these are the real world problems. You don't know how it look like. Now in this example we have downloaded a data of GDP per capita and life expectancy for different countries. So first let us see what is the data that we are importing, and then we will do something else. So this is the data that we have imported. You know that we have to use pandas and numpy to import the data. So we have index, unnamed column, then country, year, population, continent, life expectancy, and GDP. So we have 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7. And you know that index will start from 0. So 0, 1, 2, 3, 4, 5. Oh, again my mistake. This is the 0 index. 0, 1, 2, 3, 4, 5, 6, 7. Right? Seven columns. 1, 2, 3, 4, 5, 6, 7. Yes. So this is the index column, unnamed, then country, and so on. Okay. And okay, so this is the data. Right, now we will convert this data into numpy array. So when we convert this into numpy array, so you can see here 1, 2, 3, 4, 5, 6, 7. So when we convert it into numpy array, so the 0 index is this 0, 1, 2, 3, 4, 5, 6. Okay, and the last one was GDP, and before that we have the life expectancy. So we created two sub arrays from that for GDP per capita and life expectancy. How? From this np underscore data, all the rows from column number 6, all the rows from column number 5, and our task is to print the last element from life expectancy and from GDP. So we have this life expectancy and we have GDP in dollars. Life expectancy is in years. You can customize your message, right? Like this. Now, if we try to plot the line graph in between this, then it will be something like this, which is very messy, and you cannot extract anything clearly from it. So we need to shift towards another approach, and that approach is the scatter plot. When you have a time scale along the horizontal axis, the line plot is your friend. Why? Because time is linear, right? The scatter plot is a type of plot that shows the data as a collection of points. The position of point depends on its two-dimensional value, where each value is a position on either the horizontal or vertical dimension. But in many other cases, we are trying to access if there is a correlation between two variables. The scatter plot is a better choice. To create a scatter plot, we will use plot dot scatter x comma y, right? Very similar. So first understand this with a simple example in which we have x and y and we are trying to plotted. So it is not going to connect these 2 points with a line. It will just give you these dots over the x and y axis so that you can see the trend. So here I can see, okay, if x is 10, y is 5. X increasing, y increasing, x increasing, y is increasing. So I can see that there is a clear trend in between x and y. Both, if x is increasing, then y is increasing as well. Now if we plot the scatter plot over GDP with life expectancy, you can see here we have these few values. You can say that, okay, they are not making good sense, but overall you can see here it is making a good shape. So you can draw your observations from it very clearly, right? So this is the advantage. Now this is much better than this one. So in this case, the better choice is to have the scatter plot for your analysis. So that's why we have multiple options. So we will keep this till today and we will continue from this point tomorrow. Till then, take care. Bye bye. Assalamu alaikum guys. Hope all of you are doing great. Welcome to our today's session. Let's continue from where we stopped yesterday. Yesterday we started the topic of EDA, that is exploratory data analysis, and we had covered two types of plots, that are line plot and the scatter plot, and we did some basic examples from that, how we can use the range function and how we can implement the line plot and scatter plot. Also we used one dataset for the world development that has the information related to the GDP per capita and life expectancy, and we concluded till this point yesterday. Now let's continue. Today we are going to start from this point. So till yesterday we were dealing with the linear scales in x and y directions, but when we have huge data, so sometimes it is beneficial to use logarithmic scales as well, right? So this is what we are going to do. For example, here we have this x and y data set, and you can see these values are increasing with a multiplier of 10 with every proceeding value. So when we plot it with the line, it is fine. With the scatter it might not be. You can see here two dots are, three values are here while the fourth one is here, and in between we have nothing. But if we implement the log scale on x and y axes, then the quality of the graph will be improved very much. Now you can see it is following a linear pattern. Now how to implement the defining the data and plotting the plot is quite simple. Now you can apply the log on any one axis or both of these axes. How to do it? Plot.x scale is log and y scale is log, and then plot show. So it will be implemented automatically. It is quite simple. Similar thing we are going to do on our yesterday's plot, in which we have something like this. Here you can see most of the values are very closely mapped into this graph. So after applying the logarithmic scale, you can see it is distributed all over. So from this you can extract more details as compared to the previous one. So you need to explore that which type of graph, which type of scale suits best your need, and then you can do something. So here we have another plot in between population and life expectancy of the same dataset. Again, you can see it is very closely packed, right? While very few values are here. Again, we are going to apply the log onto the x scale, and you can see here now it is more clear, readable, and you can extract more details from it as compared to the this one, right? When the data is huge, then you need to think how to deal with it. So this was more about scatter plot. Now we come to the histogram. It is also called bar graph. Usually it is based on single data set. So for example, here we don't have x comma y, it is x only, and we have certain values of x. And when we want to plot the histogram, so we will write plot.hist and x that contains all the values, and then plot show is similar to the previous examples. And obviously we are going to import matplotlib.pyplot as plt. So now when we execute it, you can see here we got something like this. Basically it counts how many counts we have in this range, how many counts we have in this range, how many counts we have in this range, right? So this was our own data, but here what we are going to do, we are going to plot life expectancy graph by using the histogram. You can see here it is very closely packed, there is no gap at all in between them, and you can hardly see where is the interval. Similar thing here we have nothing, here we have two bars merged, here we have two bars merged, and here we have four bars merged together, right? While here we have all of them merged in this area, then few of them are separated. So there is a very useful feature in histogram that is called bins, which defines the interval in between these datas, right? So for example, we have this data set which defined earlier. So if I plot it without bin, so it looks like this. With the bin, it can be plotted like this. Now you can see here this data is more clear, readable, and understandable. So this is the function of the bin. You can define the interval and then you can have the graph, right? Similar for the life expectancy, we run this code, the same code with bin 5 and bin 20. So you can see here with bin value equals to 20, we have better graph as compared to bin value of 5. So again, it is a hit and trial method. You need to see which one suits best. You might have noticed that whatever the graphs we have plotted till now, They don't have any label, they don't have any title, they don't have anything, and without this plots are incomplete. So how to add labels on the graph or on the plots? It is very simple. You need to use these three commands. Plot.title, it will give the title. Plot.xlabel, it will give xlabel. Plot.ylabel, it will give ylabel, and then plot show. Now you can see your graph has xlabel, ylabel, and the title. Alright, so you can define like this, or you can define in the form of variable that the x label will be this, y label will be this, title will be this, and then when you define plot.xlabel, so you can call the variable. When you define plot.ylabel, you can call the variable. When you define title, you can call the variable. Both of these approaches are fine. You can see GDP per capita in USD, life expectancy, and world development. There is another thing that is called the ticks. What is tick? It is similar to X label and Y label, in which you can map. For example, instead of 0, 1, 2, you want to write 1, 2, 3. Instead of 0, 1, 2, you want to write 1, 0, 1, 2. Right? So this can be done as well. How? By defining like this. So we define the data, then we define that we are going to plot the scatter plot. This will be the title, this will be the X label, this will be the Y label, and these will be the ticks. So 5 will go with 5, 2 with 2, 9 with 9, 4 with 4, 7 with 7. Same for the Y as well. 10 with 10, 5 with 5, 8 with 8, 4 with 4, 2 with 2. Now when we execute it, you can see your graph will look like this: 2, 4, 5, 7 in a string instead of numbers, right? This is another example in which we have an extended list of data, so definitely it will be having more ticks for X and Y. So when we plot it, it will be similar to this one, but with more values on X and Y axes. Alright, and here what we have done, again we use the data that we have for world population. We define the labels, then we define the values and the labels, because here this is the value and this is the label. Both of these are separated by this comma, so we can define them separately and then call them with the name of their variables. So we are plotting scatter plot for GDP cap, life expectancy, plot.x scale in logarithmic. Then we are calling the plots labels, and then the title, and then the ticks. We are defining only ticks for x-axis, so this is for x-axis. And when we call this, run this, so we will have something like 1k, 10k, and 100k, like this. So these are the different approaches that as a data scientist you have to adopt, and you have to incorporate into your codes so that you can produce better output that are understandable to everyone who doesn't know about coding, right? So being a good data scientist is something else, and you need to be a good storyteller, and you need to be a good presenter of your data as well to convey your message. Then you will have your proper worth. So this is all for today. We will continue from this point tomorrow. Till then, take care. Bye bye. Hi guys, good morning. Hope all of you are doing great. Welcome to our today's session. In our previous session, we covered something um, that was adding the titles on the plot, the ticks on the plot, and the label of the plot. So we had concluded till this point that after adding all these things, your graph might look like this. Now you can see all of these dots are still uniform. All of them have the same color and the same size, which is good for the basic analysis. Being a programmer, you can understand how to get the observation from it. But to make it more appealing, it will be a good idea to vary the size of these dots, right? So for example, we have this plot, right? And all of them are of same sizes. You can see all of them are in blue color, but we can vary these the size of these plots, these dots. How? By adding another argument after the data inside this plot.scatter command, right? How it can be done? It can be done by defining the dot size, right? So the argument that you can use is x comma y, where x and y represents the data, while comma s, which represents the size, right? So in the same example, we are going to extend it, and we are going to define the size of the dot that we are going to plot, right? So this is our original graph, and here we have given another list which contains the size of the plots, size of the dots that are going to be plotted. So for example, 100, 500, 100, 500, and so on. So mostly just two numbers are there. You can vary it to different values so that you can have variable dots. So 100, 500, then 300, 400, 200, so on, right? And when we define the command, so we will give another argument which is s, that is equals to the size, and size is here. So now what will happen? It will take 1, 400. So at x equals to 1, y is equals to 4, and at this point the size of the dot is 100, right? So now execute it and see how it looks like. Now you can see this graph. It has all the dots variable, right? So this is our first point. At 1, y is 4, the dot size is this. At 2, y is 1, dot size is this. 3, 3, this is the dot size. 4, 6, this is the dot size, right? So it gives us a variation in the display, right? And this is a random selection. Otherwise, higher values can go with higher size, lower values can go with lower size. It will be more realistic in that case, right? So, but the problem is, if you have a data of 1,000 lines, then how you are going to define something for the size? It will be very difficult for you. So in that case, we have taken an example in which we have imported two data sets. First one is the population data set, and it has some numbers. You can see the point to remember here is number of rows. It has 142 rows, which is very similar to another data set in which we have the detail of year, population, country, life expectancy, and GDP per capita. It also has 142 rows, right? So that means we can map them together in order to plot something. So we have one column here, so we can take this as a size for the plot, while here we can take any two values, for example population versus life expectancy, or life expectancy versus GDP. So this will be our X, this will be our Y, and the size of the dot will be from here, from this column. How it can be done? For example, if we are going to plot GDP versus life, so first we will extract the GDP from this data. So this is the data, and from this data we are going to extract GDP underscore cap. Here we have defined. The second parameter we are going to define is the life expectancy. Again, it is from data life expectancy, this one. And now when we are going to plot it, so plot dot scatter GDP X life Y, while the size of the dot, which is the population, is pop. So now when we plot it, it will look like this. Now you can see it has huge variation in the size of the dots. Some are very tiny, some are very big, right? And yes, so this is a way by which you can map one array to another array to be treated as the size. Now to add more details to it, by changing the color of these dots, we can make it more appealing. So we started with plot dot scatter xy. This was the data that we added S for the size. Now we are going to add C as a color. So again we have created our own data set, x, y, size, and then plot color. And inside this scatter we define x, y, s. Size, it will be taken from here. Plot color, it will be taken from here. And these are the titles and labels. When we execute it, you can see here it is more appealing, right? More interactive and more appealing to us, right? Now another feature, we can change the transparency of these data points. By default it is maximum, or you can say it is by default it is 1, but we can reduce it so that this will get a little light and little dark, which is called the opacity, right? By default its value is 1, but you can vary in between 0 to 1. So if it is 0, you cannot see this dot at all. If it is 0.5, it will be very light, 0.5 a little more visible, at 1 fully visible, right? So to define this, we use this argument which is called alpha, right? The rest of the things are same: x, y, size, plot color, and again it will be added at the end in the same command. The rest of these three, you know what is the purpose of using it. So now when we execute this, you can see these dots are in color with variable size, but their opacity is changed. So for example, let me make it 0.5. It is more visible. 0.9, almost fully visible. 0.1, very dim, like you really need to find where it is, right? So this is another feature that you can add to your plot to make it more interesting, more interactive. So this is all what we can do. There is another feature that usually, if you want to label the data, that what it is, for example it is a country, right? So we can add a name here on the plot directly. Also we can turn on the grid in order to pinpoint the coordinates. How it can be done? It can be done by using two commands. First command is, this whole piece of code is similar from the previous block, so I'm going to explain this one only. So for the grid, it is very simple: plot.grid true, so the grid will appear at your plot. Now the text that you want to add on the graph, on the plot, is, for that you need to use plot.text. Then you need to give coordinates: x coordinate, y coordinate, and then the text. What exactly is the text? So we have added two text values here. Then the grid is on, and then plot show. So you can see here the grid is on. Here we have India, here we have China, and so on, right? Now we have till 50,000 here, so let's make it 29,000. So the China will be on more right. Make it 39,000. So see, it is here. Make it 80, so it will be a little bit up here, right? And for example, if I make it this, so it will be shifted towards left. So this is how you can align some text. Usually this is used for maps. This is the densely populated area, this is less dense populated area, this is the location, so on and so forth. So with this we have completed everything for two-dimensional plots with respect to x and y, right? By using the most important, not the most important, but very important library, that is called matplotlib. lib. Um, in our next session, we are going to continue with another very important library that is called Cbond, and which is used for scientific data analysis for the research purposes. So till then, take care. Bye bye.